Hello friends, welcome to SQL Server tutorial. Now we are at the final part of the subseries index maintenance. In this video, we will see how to check the index usage. So here we are going to gather statistics about the index. So how many times the index was or is used by the user or the connected session. Indexed column will improve select query performance when the column is involved in the record selection. Right? A table can have a indexed column, and when the indexed column is involved in the record selection, then it means the SQL Server will use the index. Say for example, if there is a table for a list of product and there is a column called product ID, and let's consider there are other column as well. The product ID is let's say it's a primary key column. That means it's a clustered index. So there is a index, right? And when your record selection make use of this primary, this particular column, indexed column. Say for example, select col1, col2, column 3 from this specific table. If it is product, from product, where PID equal to. So this will be used. Or if this product table is joined with some other table, say order or order detail, and if we join the order detail through product ID and this product ID, then there will be a comparison based on product ID, right? That means the column is used in record selection. So in all these cases, the presence of index will improve the performance, query performance, while retrieving the data. But write operation like insert, update, delete will see a performance overhead. In case of DML, like insert, update and delete, SQL Server needs to access the disk for table as well as indexes. Say for example, you are inserting a row in the table. So this will introduce a new product ID. Let's state 101, right? So there may be already a data structure for this product ID, and if you have a new entry, then it needs to walk through this data structure and see a slat for this 101. So for example, let's state that the slat is here and it will put 101 here. And in later stage, if this product ID is updated, then let's state that 101 is not at all there and it is 501. So it may once again need to make a traversal, remove this node and take a correct fit for this and add a row or add an entry for 501, right? When this product ID is updated to 501, there will be two operations. One is it should go to the page file, find the record and update that specific entry with 501. That means erase 101 and put 501 here. There will be other columns here in the page file. Then you should go to the index also, remove this node and create a new node. Even though it's a modification, since value is changing, it needs to adjust the tree, right? So 501 will go to a different level. Same goes for delete. If I deleted this node, then all the index below this node should be recreated. So that's why selection is quicker, but write operation like insert, update, delete will see a performance overhead. In case of DML, SQL needs to access disk space at two levels, one for the table and one for the indexes. It is good practice to monitor the index usage. When it is not used adequately, it is good not to have it because of these insert, update, delete penalties. So just check how frequently the index is used. So if there are very less index seek and scan that you will see sooner, that means the read operation or traversing operation, if it is very less compared to the insert, update, delete, then that specific column is not a good candidate for index creation. So you can leave it as it is. So, but it is up to the site or the your user database admin. So if they want, you can, but you can advise them based on the statistics, whether you can have or you no need to have the index. All right, previously we talked about one of the database maintenance view. Here there is one more dictionary view. Here it is DB index usage stats. So using this, we can find indexes with its usage statistics. Previously, we used the table valued function to retrieve the fragmentation percentage, but this view DB index usage stats will give you the index usage statistics. When SQL Server is restarted, the view does not return anything because the statistics will be collected between the SQL Server session. Say for example, SQL Server is started here on May 1st, let's state, and the server is in the running state, and on May 30, the server is restarted, right? So once server is restarted, it will stop the SQL Server services, and when the machine is rebooted, that time the server will come back. So during that time, all the statistics will get wiped out. So it will be kept in memory, and when you want the statistics, the DB index usage stats will collect the information from this built-in memory and provides you the required information. But when the machine is restarted, or if the SQL Server service is stopped and restarted, the statistics information will be wiped out. It will be removed, so you will not see anything. So it's good to run the view before starting the SQL Server. That means if you want to know the index usage statistics, so you fix a day. Since you know this is the maintenance window, May 1 to May 30, collect it on last week. That means you can pick a window somewhere between 25 to 29, and during this period you collect the statistics using this dictionary. For example, in production system, let's say the maintenance window is every Sunday 11 p.m. In this case, it's good to run this view on Friday or Saturday, or just before restarting the SQL Server. Okay, here we took an example of 1 month, and in this passage we talked about 1 week. So it all depends on your maintenance window. So allow the SQL Server to run for a specific period of time, and before the next maintenance window, collect the statistics. So that will give you a good idea of how frequent the index is used by the client applications. After finding the index which was used very less, one can disable it instead of dropping. So later one can enable it if needed when usage statistics goes high. because here we are talking about insert, update, delete, overhead, right? So when index was used very less in terms of scan, like traversing and fetching the or select operation, and if that is very less, then we can disable the index, or sometime you can even drop it. So if you sure that the usage will not go high in the future. So this will help the overhead of recreating, that means disabling it. This will help the overhead of recreating the index, especially when the table contains huge data. So when the table contains huge data, instead of dropping it, you can disable it, and in later point in time when need arises, you can enable it. So now let's see the index usage statistics. Here we are making the select statement from sys dmdb index usage stats, and we are setting a alias for it as usage. Then we use the sys indexes and we set alias as idx like we did before. On usage.objectId, index.objectId, that's one mapping, and we use index id as well. So this join also we already saw when we collected the fragmentation statistics. This time we are going to collect usage statistics. So after this from class, in the select list, if you see, we are getting the object name. Using the object underscore name, we pass the ID, and this will tell us the object name, table or view. Then we are getting the index name. Here we use user seeks, user scans, user lookup, user update. So all these are index usage data. We will talk about this soon. Where db name equal to adventure works, and in my case it is 2012, adventure work 2012. When you go to the script, the time we will modify it. So here we are talking about seek scan, right? Scan means SQL Server visits all the rows of the table. So let's talk about the product table. So seek is the operation of visiting all the records. So that is a seek operation. So usually when you go for select without any where filter, all records will be visited, and we will call that as a scan. SQL Server visits all the rows of the table. We call that as a scan. Next, if you say seek, SQL Server looked for a subset of rows in the table. Subset means here we may be using the where condition to pick a specific record, and let us state that this is the indexed column and we are collecting statistics for this. So seek all, scan means visit all the row, seek means compare and get only the selective row. That is what called seek. Update includes the insert, update and delete action. So when there are multiple insert and update, this column will get affected, right? So if you insert a new column value, if it is a primary key, definitely there will be data. Each insert will have a primary key, and if you have index on another column unique, there is a high possibility if you doesn't enter null, only one null is allowed in terms of unique. So we can say here also data will get entered on the insert. So insert, update as well as delete. All will modify the indexed column, or if the update and delete affects this indexed column, that will be counted as one here in the user updates, right? That's user update. All this data helps in deciding how important the index is. So you will get the usage statistics, and if you see a high number, then the index is required. All this data helps in deciding how important the index is and how often it requires a maintenance window. So not only it helps in deciding whether index is required or not, it also helps to state how often a maintenance window is required. Maintenance window means the index maintenance window in terms of reorganize as well as rebuild. So if you see a huge number of updates, right, huge number of updates, then you may tell to your DBA that there is a high possibility of fragmentation for this specific index by comparing with other indexes. Say for example, you restarted the SQL Server on Sunday 10 a.m. and in Tuesday 10 a.m. you are collecting the statistics, and in this maintenance period, let's state that there are two index 1 and index 2, and we are examining only the user updates, and index 1 tells 1000 updates and index 2 tells 85,000 updates. So that means you can tell to your DBA that index I2 may need a fragmentation window quite often compared to I1. So since there is a huge update on this, it will most probably get fragmented quickly than index I1 because there is only 1000. Similarly, by looking at this scan and seek, there's one more here, lookup, and using that you can state, say for example, for index I1, the seek and scans are, let's state that 8,85,000, and for index I2 it is just 700, right? So here scan is very less, but the insert update operation is taking place very quickly. So that means this will get fragmented, and at the same time there is less scan, so you will not be getting the advantage of using the index. So I1 is a good candidate for the index, right? So you can come to that conclusion also. So I1 stands a good chance of creating the index for that specific column. I2, you can advise your DBA or the site owner stating that it's not good to have index for this one, because you will get penalty in terms of the updates and insert, right? Because there is less usage on scan and seek as well as lookup. All right, so that's one thing. Now let's go to the demo. So here, if you see, we have a select star from sysdm db index usage stats, and this view will give us the index usage statistics. Let's run this script and see what are all the columns there, and by looking at the return result, you can see there is a database ID, object ID, index ID, user seeks. You know what is meant by user seeks, user scan, user lookups, updates, right? So these 4 columns are sufficient for us to make a decision. Here you will be seeing some numbers, right? That means I haven't used this Adventure Works database quite often. And if I go to SQL Server services, let me close this also, because I'm going to close the or restart the SQL Server services. So this is the MS SQL Server. This is the core service, right? We will stop this and start again. Okay, since we restarted it, I'm checking this again. And if you see the scan, see, call, reset, and you are seeing very less number of data here, only 5 rows, right? Because since we restarted the SQL Server, the index data are reset. Also you can see the scan is showing 1 only, lookup is 0, 6, lesser. Previously we saw 15, 16, all those, right? All right, to get a meaningful information, here we are seeing numbers, right? ID also number, object ID is number, index ID. So we will get a join like we did previously while collecting the fragmentation percentage. The same way here we are using the data. Here we are using two views. One is usage statistics and another one is indexes view. And we are joining it based on object ID as well as index ID. Adventure Works is the database, and you know this, we are getting the name of the object, name of the index, then user seeks, scan, lookup, and update. Now let's execute this. This time it gives a meaningful information. Object name is product review, and job candidate is one object, document is one object, and here it shows the index. And the usage statistics tells that user seeks is 1, scan is 0, lookup is 0, and user update is also 0. So now here if you see, we have select star from person.person. Person is the schema and this person is the table, right? Table Adventure Works 2012, that's the database. Person is the schema, the next person is the table. And here, since there is no filter condition, this will increase the scan entry. So here user scan is there, right? At present we are not seeing any entry for person. Once I execute it, I executed it one time, execute it 2 times. That's what I'm going to do. Now I executed it 2 times. Now if I run this query again, you can see person is entered, user scan is 2. That means the table is scanned for 2 times, and since here we specified star, that this will include our indexed column as well. So user scan is 2, and if I execute this one more time, you will be seeing user scan as 3. Here I'm executing the query manually using the SQL Server Management Studio. Now you can think of a front-end application that is making a query like this. It can be a front-end application or some other stored procedure that is making a select statement like this. In all the cases, the table will be scanned and you will see the user scan here. And this tells that in the person table, the index name business entity ID is scanned 3 times here. So the scan here is talking about business entity ID, right? That's the primary key on the person, I guess. Or if you go here, you can examine it quickly. So we've done that many times, so we don't want to repeat. So anyhow, this is the index on the object name person. Now we will run one more query. Select star from person.person, where person.business entity ID. This time we are performing the seek. We will execute 3 times the seek operation. Seek operation in the sense we are not scanning through all the entry in the person table. Here we are picking specific rows and we are using the index seek. Right now, let me execute this one time first. And before that, if you see, the seek is 0 here. Scan is performed 3 times, seek is 0. Now I am executing it one time. And if I run our statistics data, it tells that user seek is 1. Right? Now let me run this 3 more times. 1, 2, 3. Okay, mistakenly run one more time. It's okay. So this will give 4 on seek. Here if you see, there are 5 index seek. Scan is 3. Right? Now scan will go as 4. So this will give an idea of how the index is used. Here update is 0. I don't want to disturb this data. So if you run a update statement, then you can also see how frequently the index is updated. Index means you have to make an update in such a way that it will affect the business entity ID. You can remove a specific row based on the business entity ID, or you can add a row, or you can modify a row with a different business entity ID. So this will affect the underlying data structure, right? So you will be seeing a count here. Here update in the sense it's not only the update statement, it is a combination of insert, update and delete. So these 3 numbers together and this update, it tells you whether index creation will go as a overhead or it will benefit your user. If there are more seek and scan and lookup, and that is 60 to 70% higher than the user updates, then the specific index is good in usage. So you can keep the index. So at the same time, when the user update is more on the index, you can know that the index will get fragmented quickly. So the challenging situation comes all these 3 together in a week. Say for example, if it comes 10,000 and the update also comes around 10,000 or 11,000 or 9,000 like that, it is very hard to make a decision. And the index is good in terms of scan and it is getting updated as well. So it frequently get fragmented. So there is no other go. We have to live with that because of the usage. Alright, here we saw how to calculate the index usage. That's all here in this video. And we are ending the index maintenance sub-series. Thank you for watching. Bye.